Hello, welcome back. My name is Olori Godwin and this is MOJ Economics. So the topic for today is definite integrals. Now I mentioned in the last video that I'll be talking about definite integrals in the subsequent video. So here we are. And okay, so what we've done so far in under integration generally, integration by substitution, integration by parts, economic applications of integration, and here we are. And in the next video we'll be talking about another kind of economic application of integration, which is in talking about consumer surplus and producer surplus. Okay, so before we proceed, let me make an important announcement which I make at the beginning of every of our videos now, which is the fact that please, dear audience, dear beautiful people, wonderful ladies and gentlemen, please make sure you watch our videos online. Even if you are going to download them, please make sure you watch them online first, or find time to watch them online. Now the reason being that YouTube considers videos that are not watched online bad videos and fails to recommend them to potential viewers. I know there are a lot of people out there that have been needing this kind of platform, and we actually need your help, as you've been helping us all of this while to achieve a lot of great feats. For example, this particular period, I think we have 1,570 subscribers, and that's because of your efforts, sharing and all of that. Please, we need your help once more. Please make sure that you watch these videos online. If a video is 20 minutes long and people watch for, let's say, an average of 1 minute, 2 minutes, what YouTube sees that video as is a bad video. That if it were a good video, why would people be disinterested in it after the very first minute or the second minute? So they then fail to recommend the videos to potential viewers that may be needing the videos across the globe. Please, we are doing this for a lot of people out there. We need you to reach out to them. Please watch these videos online, and please make sure that you watch them till the end. You will save them to watch later, instead of downloading and then watch when you are at your leisure. Please and please. All right, thank you. So let's get straight to the point. Definite integral is useful in calculating area under a curve using lower and upper limits. In economics, it is used in calculating consumer and producer surplus and so on. Okay, so that is what we use definite integral basically is, you have a curve like this, you have something like this, a graph like this, then you have, let's say, a line like this. Alright, so using this represents the lower limit and this represents the upper limit. And kind of calculating the area under this curve is what you use definite integral to do. So that is what it means. So this is going to be the upper limit, this is going to be the lower limit. In consumer producer surplus, we have this, and then we have this, right? Then you have equilibrium. So here represents the consumer surplus, here represents the producer surplus. So the area under this curve that gives us the first triangle, and the area under the second, under the supply curve that gives us the second triangle. These are things that we use definite integrals to get. Now the equilibrium quantity here represents the upper limit, let's say 6, and the origin represents, let's say, 0, the lower limit. So that's what we are talking about. But before we get to that, let's deal with questions like this. So if you have a function of x dx, alright, with limits b and a, whatever limit you add, whatever value you have here at the top of the integral sign is the upper limit, then this represents the lower limit. So by the time you do it, it's going to be equal to the integration of this, which is f of x, then a straight line, and you include the limit again, equals f of b minus f of a. Now, I'm going to show the meaning of all of that now. So we have this particular, let's start with here. So we have this question. Alright, so 1 integral 4 1 30 x dx. So what you do is you integrate this, you have 30x, which is what is called the function of x here, 1 plus 1 divided by 1 plus 1, right? Then plus the constant term c. Okay, then you have 4 1 here, and this is going to be equal to what? So you have 30x, so you have 30x divided by 2, right? Divided by 2 raised by 2, then plus c, okay, 4 1, which is equal to 15x squared plus c, alright, 4 1. Now what we now call f of b is simply this. Now f of b is, so we'll be having 15 x, replace x with 4 into bracket 4 squared plus c, right? Then minus f of a, which is into bracket 15 into bracket, what is a? 1 squared then plus c. Alright, so that then gives us 4 times 4, we have 15 into bracket 16 plus c minus 1 squared 15 minus times c is minus c. So minus c and plus c is going to cancel out, and then we have 15 times 16. Okay, 15 times 16 is going to be given us. Let's punch that in a calculator and see what we are going to get. 240. So we have 240 minus 15, and then our answer is 225. So that's all. So the area under this particular curve is 225. So I think that's similar to what I have here. Now let's go straight to the second question. Second question says that we should solve this. So integral 3, 0. Now let's just rewrite this. So we have 6x into bracket x squared plus 1 dx. Okay, basically speaking, so we use the substitution method to solve this. So u equals x squared plus 1, then du dx equals 2x, and then du equals dx now, dx equals du over 2x. So we then have this 3, 0 equals so this is going to be equal to 6x into bracket u, then du divided by 2x. This cancels this, so we have 3 here. So we are having integral 3, 0. So we have 3 outside, then u du. Okay. Alright. So by the time we integrate this, we'll be having u3 into brackets u squared divided by 2, right? Divided by 2, then plus c, and then we have this 3 and then 0. So we continue. U squared is, so we've integrated, right? Okay, so we then have 3 into bracket. What is u squared? U is s squared plus 1 s power 2 divided by 2 plus c, then we have 3 and then 0. Now let me quickly verify that. So we have is it wait. When I brought this up, it is meant to be a minus 1. It's meant to be a minus 1 here. So we have a minus 1 here. Okay. Then this is not this. This is not this. So we have this is minus 1. So this is going to be ln u plus c. That's why it's good to have a note to verify. Okay. And this is going to be 3 ln u. So u being s squared plus 1 and plus c. And let me see if that is what I have. Okay, so u being 3 ln x squared plus 1, then 3 is power 3 and then 0. Alright, so by the time we continue, so we'll be having this guy, we replace it with 3, so we'll be having 3 ln, we have 3 squared plus 1, right, minus 3 ln 1 squared, is it 1 squared? No, 0, 3 ln, this is 0, 0 squared, okay, plus 1, okay, 3 ln, is that it? Yeah, 3 ln, let me check again, 3 ln 3 squared plus 1, then 3 ln 0 squared plus 1. So from here we're having 3 ln 10, 3 ln, this is 9 plus 1, 3 ln 10 minus 3 ln 0 minus 3 ln 1. Now this is 0 plus 1 minus 3 ln 1. So apparently by the time you punch this in your calculator, 3 ln 10 is going to give us, please punch that, 6.9078, 6.9078, right? Then minus 3 ln 1. Ln 1 is 0. So that's 3 into bracket 0. Alright, so 3 into bracket 0 is 0, then we have 6.9078. Now that's that one. Let me quickly do the third one. So the third one is 6x. Okay, so we have integral. So that's the answer, 6.9078. Integral 6x and x squared plus 1 minus 1 dx. Apparently we cannot use this stuff. Can we use, wait, did I write? Oh my god, I wrote the same question twice. Now let's say this were 6 6x squared. Let me just change it that way. Let's say this was 6x squared. So if you have something like this, what is the okay, so what is here basically? So we have 3 0 3 0. So let's say this, yeah, what we have here, all right, by the time we differentiate this 2x, so 6x squared divided by 2x is not going to be given as a constant. So what we need here is an understanding of integration by parts. I recall that the formula is fx gx minus integral f prime x, right, gx dx, right, and fx is going to give us 6x squared, such that f prime x will give us 12x, okay, 12x. Then this person, okay, this is g prime, okay, so we have g prime x is going to be g prime x is equal to s squared plus 1 raised to power minus 1, okay, so gx is going to be integration of g prime x, so integration of g prime x dx is same thing as integration of g prime x squared plus 1 s squared plus 1 raised to power minus 1 dx. So and g prime x now, gx equals wait, why did I put this again? Okay, g prime x, okay, so gx equals, when you have that, by the time you integrate this raised to power minus 1, you'll be having ln x squared plus 1, then plus the constant term, alright, so x raised to power minus 1, okay, that's that. So we then continue, just hope there isn't any mistake on the board. Okay, we then continue with, so we have everything we need. So integral 3 capital, okay, let me do it. Integral 3 0 6x squared x plus 1 minus 1 dx is then going to be f of x is 6x squared into brackets ln x squared plus 1, so let me just remove the c, then minus integral, by the time we integrate 6x squared, we have 12x ln x squared plus 1. Oh my god. Sorry, the question was getting more complicated than I imagined, so I decided to change the power here to -2. So the power here is no longer -1, it's -2. So just kind of do it with flashback, then change what you have here to -2. It was -1 initially. Now every other thing is the same, except g prime x now is going to be x squared plus 1 raised to power -2 instead of x squared plus 1 raised to power -1 that we had initially. And by the time we do g of x, when we integrate g prime x, so we're having x squared plus 1 to the power -2 dx, and that will give us this x squared plus 1 minus 2 plus 1, then this equals x squared plus 1 to the power -1 divided by -1, and minus s squared, minus s squared plus 1 minus 1 then plus c. Right, so I want to use that now. So sorry for the initial error. Alright, or initial unnecessary complication. So 6x squared plus this dx then equals, so we have f of x to be 6x squared, right, into bracket g of x, which is minus s squared plus 1 raised to power -1, then minus integral f, so you have 12 integral 12x into bracket, integral 12x into bracket, then minus s squared plus 1 raised to power -1 dx. I still think there is an necessary complication here as well. Okay, and that would then give us, okay, I couldn't add the 3 and 0. Anyway, let's continue. So here we'll be having minus 6x, okay, no, we're having 6x squared and minus, kind of, okay, you can just say okay, divided by minus s squared plus 1, right? Then minus integral, nothing can, so we have to do integration by part here again, so which is because I just formulated the third question, so it's giving us unnecessary complications, because at this point there is another complication, which is what we have to do here. All right, which is what we have to do, and so it's not getting funny. So I would like to stop solving this. Not that it is unsolvable, but it is presently beyond the scope of what we intended to treat in this particular class. So let's just leave that where we left. Let's just leave it at this point. So in another video, we continue to solve this and then show what we are supposed to get. All right. So from there, I solved 2 other questions, and let's just use the understanding of that to attempt this assignment. So we have an assignment to evaluate the following integrals. You have this x raised to the minus half plus 3 raised to the half, then the limit being 6 and 1. Number 2, integral upper limit is 10, lower limit is 0, then 5e raised to the minus 5x dx. And number 3, integral upper limit is 5, lower limit is 3, 6x e raised to the power s cube plus 12. Now s cube plus 12 dx. Alright, so that is what we'll be doing as assignments. If you can leave your answers in the comment section, please do so. Make sure that you like this video if you enjoy it. Leave comments, comment us for what we do. We'll gladly appreciate it. And please share this video, share this channel with your friends. Just copy the link, share on your WhatsApp status, on your school WhatsApp groups, your class groups, your school groups, your department groups. Share it everywhere. Share it on Telegram, share it on Facebook.